Hello students, today we begin with the chapter of current electricity. We have divided this chapter into 6 lectures, and in today's lecture let us introduce ourselves to the basic meaning of electric current drift speed, and we will also discuss Ohm's law. Let us first try to discuss what is the meaning of electric current. In the topic of electric current, generally 4 types of current will be introduced. First is, what is the meaning of average current? First we will try to understand what is the meaning of average current. Then we will understand the meaning of instantaneous current. Then we will talk about what is the meaning of conventional current. And then we will try to understand what is the meaning of electronic current. You understand, these are the 4 terminologies. First of all, we should try to understand. Now you see, this average current is simply the total charge flown over a particular time interval. You can define average current as total charge upon the time interval in which this charge has flown. You understand? If you talk about the unit of this current, SI unit is ampere. SI unit is ampere. Symbolic representation is capital A because it is on the name of a scientist. SI unit is ampere, and mind you, this is one of the 7 basic SI units as well. Now, if you talk about instantaneous current, then this instantaneous current will be written as dq by dt. Q represents here charge and T is time, rate of flow of charge at any particular instant. That will be instantaneous current. For all practical purposes in our lecture, we generally talk about the average current and not the instantaneous current. Also remember that this current is scalar quantity. Remember that current is a scalar quantity. Because even if a current has a direction, but since it does not follow the vector laws of addition, that is why current is treated as scalar quantity. Now, if you talk about conventional current, then remember that conventional current is the direction of conventional current is taken in the direction of positive charge flow. Remember that in a particular situation, the electric current can be due to a positive charge flow, positive ions, and maybe due to negative charges, say electrons. But whenever we are using the term current, it is understood that this is conventional current, the direction in which positive charge is flowing. But electronic current, as the name suggests, is due to flow of electrons, is in the direction of flow of electrons. You understand? Conventional current is in the direction of positive charge flow, and electronic current is in the direction of negative charge flow. So essentially both these currents will be opposite to each other. You understand? Let's suppose in a single direction positive is flowing and negative charge is also flowing. Then the flow of positive charge will be treated as the current or conventional current, but the current due to electrons, if you convert that current into conventional current, then both of them will be having opposite direction. So remember that, note that both these currents have opposite direction. Both these currents have opposite direction. For example, in a particular situation, let us suppose you have some space in which positive charge is flowing in this direction, and say negative charge is also flowing in this direction. Maybe a case of electrolysis, or maybe cosmic rays flowing. You do not know what are the kinds of charges which are flowing there. Let us suppose in a direction positive charge as well as negative charge is flowing. For your convenience, let us suppose I am writing the current due to positive charge as 2 ampere and current due to this negative charge I am writing 1.5 ampere. Let us suppose the current due to positive charge is 2 ampere and current due to negative charge is 1.5 ampere, and both these charges are flowing in the same direction, and I ask you what is the net current. Then you will write in this situation that net current is 2 minus 1.5 is equal to 0.5 ampere. You understand? This is because the positive charge flow is the conventional current direction, but whatever is the current due to negative charge, the actual conventional current is in opposite direction. So the net current will be subtraction of these two. But now let us suppose you consider another situation in which the positive charge is flowing in left to right direction, but negative charges are flowing in right to left direction. As usual, let us suppose the positive current is 2 ampere and the negative current, as we had just now, let us suppose this is 1.5 ampere. Now I demand what is the net current in this situation. Then remember that this negative current, if it is converted into conventional current, what will be its direction? Its direction will be opposite to the actual flow, that is in this direction. So the net current will be summation of this 2 ampere and 1.5 ampere. So if you write what is the net current, then net current will be 2 plus 1.5, this is 3.5 ampere. And what will be the direction of this? What will be the direction of net current? It is in the direction of positive current flow, that is left to right here. Here also, what is the direction of net current? It is in the direction of positive charge flow. You understand? If the value is 0.5, that means the net current is flowing in left to right direction. So this is the meaning of average current, instantaneous current, and what is the difference and similarity between conventional current and electronic current. Now let us talk about the meaning of drift speed. Now let us try to understand what is the meaning of drift speed. Symbolically, this is represented as small v and subscript is d. This subscript d stands for drift. This is the drift speed representation, and let us try to understand the concept behind it. If you imagine a conductor, let us suppose in a conductor you try to see what is inside microscopically, then you will find there is a random motion of electrons. Here I have drawn a straight line that is representing any of the cross section you can take. This is a kind of, you can say, mean line. If you are simply keeping this conductor like this, then you will find there is a random motion of electrons from right to left and left to right. If you try to see what is the overall current flowing in this conductor, then that will be 0, because net flow of charge is 0. But now let us suppose you apply some external voltage on this conductor. Some external voltage has been applied on this conductor. Then this is on higher side, higher potential. This side is on lower side, lower potential. Even now the random motion of electron continues. But in the presence of this positive voltage here and negative voltage here, you can understand that the overall flow of electrons, that will be to the left side. Why? Because now electrons are experiencing a force due to this higher potential. It is something like, you can say, an electric field has been set up in this conductor, which will try to कीप पुलिंग द इलेक्ट्रॉन्स टू द लेफ्ट साइड. इलेक्ट्रॉन्स मूव करेंगे, उनका कोलिजन होगा, फिर से वो वापस जाएंगे. बट यू सी ओवरऑल टेंडेंसी विल बी टू मूव ऑन द लेफ्ट साइड. द mean line which you have drawn, you will find that overall these electrons are oscillating or moving about the mean line. That mean line itself is shifting now. हो सकता है पहले इलेक्ट्रॉन इस लाइन के अबाउट रैंडम मोशन कर रहे हो, थोड़े टाइम के बाद you will find that the random motion is taking place about this line. After some time you will find the random motion is taking place about this mean line. You understand? जो mean line है वो धीरे धीरे आपको इधर शिफ्ट करती हुई दिखाई देगी. हम उसको सेंस कर रहे हैं. एक्चुअल वॉचिंग ऑफ द इलेक्ट्रॉन्स इज नॉट पॉसिबल, बट ओवरऑल मेजरमेंट अगर हम करेंगे तो वो मीन लाइन हमें थोड़ी लेफ्ट की ओर शिफ्ट करती हुई अपीयर होगी. एंड जो ये मीन लाइन की स्पीड है दैट इज कॉल्ड ड्रिफ्ट स्पीड. यू अंडरस्टैंड? सो इट्स अ हाइपोथेटिकल कॉन्सेप्ट. ट्राई टू रिमेंबर सर्टेन points here. It's a hypothetical concept. It's a hypothetical concept. The actual speed of electrons is very high, but the speed with which this mean line is shifting, that is very small, and that we are calling drift speed. इट्स वैल्यू, ड्रिफ्ट स्पीड की वैल्यू अप्रोक्सीमेटली हम समझते हैं 10 to 100 माइक्रॉन्स पर सेकेंड. यू अंडरस्टैंड व्हाट इज द मीनिंग ऑफ माइक्रॉन्स? माइक्रॉन्स का मतलब हुआ 10 to the power -6 मीटर. सो ओवरऑल इनकी जो वैल्यू है बहुत ही कम है. अप्रोक्सीमेटली इफ यू सी 10 to the power 5 और 10 to the power -5 or 10 to the power -4 meter per second. I have written this value because in your exam also regularly we ask what is the numerical value, approximate value, what is the order of drift speed. So remember that drift speed is having a value around 10 to the power -4 or 10 to the power -5 meter per second. And इस कॉन्टेक्स्ट में यू कैन डिराइव अ वेरी इंपॉर्टेंट फॉर्मूला दैट करंट इज इक्वल टू NEVDA. व्हाट इज द मीनिंग ऑफ दिस N? N का मतलब है नंबर ऑफ इलेक्ट्रॉन्स per unit volume, number of electrons per unit volume, per unit volume of what? Per unit volume of the conductor you are taking. That can be calculated, that can be given. This E is electronic charge. This E is electronic charge. And A is basically the cross-sectional area of the conductor. If you think that this conductor here has a cylindrical shape, then you can understand this is the cross-sectional area we are talking about. This is the cross-sectional area of the conductor we are talking about. A is, for cross section I am writing C/S. This is cross sectional area. And be careful, this cross sectional area is taken perpendicular to the direction of current flow. This A is cross sectional area perpendicular to I, perpendicular to the direction of current flow. You understand? This is the formula you can derive. This is also, you can say, an independent relation. ये आप I is equal to डेल्टा Q by डेल्टा T से भी डिराइव कर सकते हैं. इस कॉन्टेक्स्ट में एक और टर्म हम इंट्रोड्यूस कर सकते हैं. वी कैन इंट्रोड्यूस अ न्यू टर्म, दैट इज करंट डेंसिटी वेक्टर. करंट डेंसिटी वेक्टर current density vector is denoted by J vector. It is defined as current upon area. Remember that current is a scalar, area is also a scalar, but this is our convention. ये हमारा convention है that current density will be defined as a vector quantity. Remember that? So if you try to express this current density vector in terms of NEVD, then you can write it as NEVD vector, because I was NEVDA, I upon A, that is defined as J vector, that is current density vector, and that will be written as NEVD vector. Now we are prepared to discuss Ohm's law.